Your FastMCP server is crashing silently, and you have no idea which operations are failing or how often, let alone why. We'll build error handling middleware that automatically logs every exception, tracks failure rates by operation type, and preserves the original error while adding your own monitoring layer. The pattern uses MiddlewareContext to identify failing methods and maintains error statistics without suppressing the actual exceptions. Import logging. From FastMCP server middleware, import middleware, MiddlewareContext. Class simple error handling middleware. Def init self. Self logger logging, get logger, errors. Self error counts equals. Async def on message, self context. Middleware context call next. Try. Return await call next, context. Accept exception as error. Hash log the error and track statistics. Error key equals f-type error. Name context method. Self error counts error key equals self error counts. Get error key 0 plus 1. Self logger error f error in context method. Type error name error. Raise. This demonstrates the middleware pipeline pattern for cross-cutting concerns in RPC systems. The implementation shows an error-handling middleware that intercepts all messages, logs exceptions, and maintains error statistics without modifying the core business logic. What makes this pattern distinctive is its ability to inject behavior transparently across the entire request lifecycle while keeping the middleware itself decoupled from specific operations. The pipeline works by wrapping each request in a chain of responsibility, where each middleware can inspect, modify, or short-circuit the request before delegating to the next layer. Error handling middleware specifically leverages try-catch blocks around the call next invocation to centralize exception handling, ensuring consistent logging and metrics collection regardless of which tool or resource fails. This separation of concerns means your tools focus purely on their domain logic, while infrastructure concerns like monitoring remain externalized. This approach matters because it solves the problem of scattered error handling and inconsistent logging across distributed systems. By consolidating error tracking in middleware, you gain uniform error reporting, operational visibility, and the ability to implement circuit breakers or retries globally. The trade-off is slight overhead per request, but the benefit, maintainable, observable systems, far outweighs the cost for production-grade RPC servers. Let's break it down line by line. Import logging. Imports Python's built-in logging module for structured error reporting. This enables consistent error tracking across the middleware, replacing ad hoc print statements with production-grade logging. From FastMCP server middleware, import MiddlewareContext. Imports the base, middleware, class, and MiddlewareContext type from FastMCP's server middleware system. This establishes the foundation for creating custom message processing layers that intercept and handle requests before they reach the main application logic. Class simple error handling middleware. This defines a middleware class inheriting from FastMCP's middleware base. Middleware intercepts and processes messages in the request pipeline, enabling cross-cutting concerns like error handling without modifying core logic. The pattern keeps your business logic clean while adding reusable infrastructure. Def init self. This initializes the middleware instance, sets up the error logger, and creates an empty dictionary to track error statistics by type and method. Standard constructor pattern for stateful middleware components. Self-logger logging, get logger, errors. Initializes a dedicated logger named errors for centralized error tracking. This follows Python's standard logging pattern, isolating error messages from other application logs for easier monitoring and debugging.
Self-error counts equals
initializes an empty dictionary to track error occurrence statistics by error type and method. This enables monitoring of error frequency patterns, helping identify problematic endpoints or recurring exceptions. The key combines the exception class name and method name for precise categorization.
async def on message, self context, middleware context call next.
This implements the FastMCP middleware interface, defining the required on-message handler. It receives the message context and a call next function to continue processing, enabling pre-post processing of every request. The async signature supports non-blocking operations in the middleware chain.
Try.
This establishes an exception boundary using try except. It wraps the message processing to catch and handle any errors that occur during execution, while still allowing the original exception to propagate after logging. This is the standard defensive pattern for middleware that must observe but not suppress errors.
Return await call next context.
This delegates message processing to the next middleware in the chain. The await call next context pattern enables the middleware pipeline, where each middleware can pre-process or post-process requests while maintaining the original flow. Without this, the chain would terminate prematurely.
Accept exception as error.
This is a catch-all exception handler. It captures any unhandled errors during message processing, preventing crashes while allowing the error to propagate after logging. The pattern ensures graceful failure handling in middleware pipelines.
Hash log the error and track statistics. Error key equals F-type error. Name context method.
This creates a composite error key combining the exception type and method name. It enables per-method error tracking, so you can identify which endpoints fail most frequently and with what error types. The pattern ensures statistical analysis of error distributions across your API.
Self-error counts error key equals self-error counts. Get error key 0 plus 1.
This implements a running error counter per error type and method. The get error key 0 pattern safely initializes missing keys to 0, then increments the count. This enables tracking error frequency for monitoring and alerting.
Self-logger error F error in context method. Type error name error.
This logs the error with structured details, method name, exception type, and the actual error message. Structured logging ensures errors are searchable and actionable in production logs while preserving the full context for debugging. The original exception is re-raised afterward to maintain the error propagation chain.
Raise.
This re-raises the original exception after logging, preserving the error chain. Critical for middleware patterns where you want to log errors, but must maintain the original failure behavior for upstream handlers. Error handling pattern. This simple middleware demonstrates FastMCP's consistent error handling approach, wrapping every message in try-catch blocks while preserving the original exception flow. The error key combines exception type and method name to create meaningful statistics without losing context. Always re-raise the exception after logging to maintain proper error propagation through the middleware chain.
The error that is caught becomes the error that is known, yet remains the error that was never handled.